Hello.
Hello.
All right. Hello. All right. So we made it through the countdown. Let me turn off this. We're still going through a bit of a transition because we are using Zoom now, and with Zoom, it makes us launch the webinar. And because we launched the webinar, we can't have like the YouTube slot saved as a live stream. We're still trying to figure that out because we like to have the YouTube slot just kind of there for like a week ahead of time, but we can't do that like this. So we actually have to launch it the day of. So let me just get this stuff set up now. Cool. And YouTube is just going to have to be patient for us. I have this, and I have this. All right. I think we are ready to go. So I'm going to start. Hello, everyone. Welcome to 96 Boards Open Hours. My name is Robert Wolf. Today is January 3rd, and this is episode 129. Today, we are going to be speaking with Ed from Packet. Ed, I've known for actually some time now. I think we met back in, it was the Open Source Summit, right? Los Angeles, a couple of years ago now?
Yep.
Yeah, that was the first time we met in person. So we have a great episode in store. Today, we're going to be speaking with Ed, like I said, about Packet, and we're going to be speaking about ARM servers, and we have a bunch of good questions for him. I'm hoping that anyone on the call, if you're on YouTube, we do have the link to the Zoom channel that we're in. So we are letting anyone come on over to the Zoom channel. You can join us over here. We'll make you a panelist. You can turn your video on with us, have a discussion, talk with Ed. He's been doing this for a long time, and we're going to learn all about him and the stuff that he does at Packet. So that being said, Ed, I do have to just run through a few announcements. Is that okay? Give me one sec.
We're good.
Awesome. Thumbs up. Perfect. So I want to talk about real quickly last week and the week before what we ended up doing. Share some video links of the last episodes that we did. But last week we took the day off. This is one of the first times we've done this. I think like since we started the show, I actually took 2 days off last year. So 2 Thursdays off last year. Last week we didn't have an episode. The week before that we had a great tech talk. It was really fun. We kind of just hung out in the channel, and I'm just going to start sharing these in the Zoom channel, but then Sahaj will move them over to the YouTube. If I can find out where the chat is. There we go. So chat, and this goes to all people, all panelists and attendees. So these are some links to the videos that we had last week, 2 weeks ago, and the week before that. So we did a tech talk with kind of the team. Sahaj was there, a bunch of other people were there. And then we did an interview with Douglas Estevez. I'll put Douglas. Really fun to talk to him about IoT makers and the work that he's doing down in Brazil. We've had one blog be released since we got back from holidays. That was about Debian snapshot image for the high keyboard. And this is actually really cool work that Mani did. So maybe if we have time at the end of the episode, maybe Mani can talk to us a little bit about that. And my last announcement here is that we're going to be doing a Dev Day webinar showcase with Hackster Io towards the end of this month. I believe it lands on January 22nd. For anyone who's interested in registering to this, it should be a pretty cool event. There are a lot of speakers. In fact, I noticed that David from Mini Nodes is on the call right now. He'll be there. We're going to be talking about this solar kit, all sorts of really cool stuff, but the general theme is going to be AI. So join us for that. I'll share the link right here, and it should be a good time. Make sure you sign up. Now, at the end of the call, I want to share a bunch of really cool 96 boards that we've released in the last several weeks, last month, say. But before that, let's go into our segment. Featured guest, Ed. How's it going, man?
Pretty good.
Good. Welcome to Open Hours.
Staying warm here in Michigan. It's a toasty 52 degrees in my lab here. So.
Oh my goodness. It's actually gotten really cold here in San Diego. I mean, I know I'm spoiled, but like we're in the high 40s, I think, and 50s. So I don't have a heater in my room, but this is still really cold for me.
Turn on all the computers and all the radios and I'm fine.
Yeah, that should work. So Ed, talking about you, usually I like to kind of get to know, or I'd like everyone to get to know who we're interviewing and who we're talking to. So maybe you can kind of give us the Ed origin story. Who is Ed?
Well, let's see. So I've been doing work on the internet for a long time. Got started while I was in school at the University of Michigan back in the mid 80s, and got involved with early internet technology. So the networks were really slow. It was like a 56 kilobit internet that mostly didn't work because it was always congested. And people either had very expensive computers online or nothing at all. And I was working on IBM PC class machines back in the day, and found a bit of software from a fellow named Phil Karn, KA9Q, which was a internet network operating system for your PC. And Ethernet cards it would work with. It would work with radios, although I didn't have a radio license back then. And just got involved in like figuring out how TCP/IP works by watching it go very, very slowly over a congested network. And took that. I've done a whole mess of jobs in the last 30 years. Worked for Cisco for a while, ran an internet service provider for a while, got involved with very early internet electronic commerce, a company called First Virtual Holdings. Took a detour into the news industry and worked for a local newspaper for a while, which very much helps the process of writing a bunch of words to a deadline. And then was working a couple years ago on a solar thermal power station, which had a Raspberry. We decided to put a Raspberry Pi in the middle of this solar farm to act as a data acquisition device and as a controller. So that was the sort of first time I had worked with small ARM class devices, and we pretty quickly discovered that the real challenge for these systems was not how powerful they were for the tasks that they were doing, but the difficulty was getting a development environment for them so that you could actually cross develop on things and not have to drive 100 miles to the station out at the side of a highway in an unheated garage to try to update it. So just working on development environments for, in this case, it was a Pi 1. It was a 512 megabyte single core ARM v7 machine. I guess you'd call it a machine. And then after doing that for a couple of years, the project kind of tailed away, but still interested in it, and got involved. I've been using Twitter for a long time, and struck up a conversation with a fellow named Dieter Reuter, who does a project called Hypriot. They were working hard at it for a couple of years, doing this project of cross-development environments so that you could build a full operating system and load it and configure it and everything, and build it on a fast machine. And he introduced me to the folks at Packet, who had this, at the time, brand new 96 thread or 96 core server machine. He said, "You got to try this out. It's so fast," because I had been used to these little tiny slow things. So got involved with that. The story diverges there a little bit. Jacob Smith, who I work with at Packet, claims that he discovered me on Twitter. I think I discovered him, but in any case, it worked out. And got involved on first just as a beta tester of this new, at the time, new Cavium Thunder X system. I did what I normally do. You download some software, you try it out. It doesn't quite work sometimes. You go to GitHub, you find the project, you open up an issue, you explain what your circumstances are, and you try to diagnose it as best you can and look for some help, knock over a bug, get things to work, and then move on to the next thing. So after doing that for a couple of months, just as a beta tester, got a little bit of funding from Packet to continue that, and then worked up a project proposal to ARM to actually do the whole Works on ARM project, which involves some combination of being very enthusiastic about the things that work perfectly well on ARM and telling use cases and stories of ARM server successes, and then the day-to-day nitty-gritty of keeping track of uh, dozens, I think the sort of low hundreds of open source projects, and making sure that at every step along the way they do a better job.
Quite the path.
It's quite a trajectory. You know, I have to compare the little single board computers that you have behind you on that display there. Like any one of those machines is faster by far than the VAX 11750 that I got started on. Right.
Yeah,
It might, you know, it's a complete replacement for that sort of like, you've got a machine, it's not very fast, but it's doing a lot of things. You're going to sit in the corner, you're going to babysit it, you're going to, you know, except that they're like 35, you know, they're like 30, 50, $80 and they're tiny. So that's crazy. Yeah. These were, you know, in my memory, these were, you know, $30,000 machines, not $35 machines.
I've told this story several times. I still think it's crazy. It's one of my fondest memories. I think sounds lame, but it's one of my fondest memories of college. I think I was sitting in a class waiting for it to start, and my friend comes up to me with this like super excited look. He's like, "Oh my God, you won't believe it! This credit card sized board." You mentioned Raspberry Pi, you know, like the first one that ever came out. Like, this credit card sized board is a full computer and it's like this big and it only costs $25. And I'm like, no, you're lying. That can't be real. And then turns out that it was, and it's like, okay, cool. And then all of a sudden, you know, then you start seeing all these really cool boards come out. The Raspberry Pi starts doing more iterations, and now it's this big thing. So Ed, now I want to talk to you a little bit, like, you know, this is a cool story. So you've been at ARM for a long time. Every person that I've talked to where you come up, it's Ed's a genius. Ed's a really smart guy. Ed knows what he's doing when it comes to ARM. So I want to ask you, you know, I mean, like, let's just go to the roots of it. You know, tell us, in your experience, you've worked with x86 machines, you've worked with ARM machines. You know, can you just give us, like, you know, your quick view, like, what's your differentiation between, you know, working with ARM architecture and x86 architecture?
Well, so the biggest difference is the market. In the x86 world, there's Intel and there's AMD, and that's pretty much what you get to pick from. In the ARM world, there's all kinds of server class, PC class, laptop class, embedded class systems. There's this whole range of different systems. They're all a little bit different. Some of them boot really easily. Some of them are a little bit crazy to get started. You know, each one has a slightly different design. There's a bunch of different designs. Some people do their own. So it's just a lot more diversity, a lot more variety. In the x86 world, things have pretty much homogenized around the needs of Microsoft and around the needs of server folks. In the ARM world, there's a lot more differentiation that maybe doesn't add too much value sometimes, but there's just a lot of differences between things. And then the biggest difference between the ARM world and the x86 world, in my view, the ARM world has a bunch of little things and enough big cores to be, so there's enough server class stuff, there's enough embedded class stuff. In the middle of the market, where you'd be looking at, you know, the class of machine that you'd sort of characterize as a powerful desktop, the ARM world is just missing that. The Intel world has a bunch of these NUC shaped and sized machines, 16 to 64 gigabytes of memory, a modern processor, enough storage to do something fast, you know, basically a unit of computing that's fairly powerful, that's a couple $100 or more. The ARM world doesn't have that class of system. And so it's been challenging to sort of bridge that gap between, like you say, 25, 35, 55 small single board size things and 1U, 2U rack mount servers, trying to find that sweet spot in the middle and, prepare for the eventual day, prepare the software stack, which has been most of what I've been doing, prepare the software for the day when that sort of device emerges to be what people are using.
Yeah, you mentioned the Nook, and I was actually just trolling my internet, my Twitter feed, right? And I just noticed a post from John Masters, and for people who aren't familiar with John Masters, like Red Hat extraordinaire, working on ARM servers for a long time now. He actually wrote a post, and I can quote it because I went and searched for it real quick. But it says, "We need an ARM Nook that is under $500. At most, 1,000 is acceptable. It needs to be 500 higher. And workstations are great, but they are more niche market." This is kind of a big deal. Like I've heard people talk about this for a long time. Getting that powerful, machine that you can work with at a low cost, right? Because
right.
Even 96 boards released the developer box. I don't know if you saw the one from Socionext.
Socionext, yeah.
Yeah, and people are starting to get there. You also have the the Thunder X2, which is up there, but cost-wise, not so friendly.
Sure. It's a powerful machine, but it's a server class system, right?
Yeah,
so
absolutely.
trying to find that sweet spot in the middle there. The world that I came up with started out with Vaxes and Sons and workstation machines taking over for mini computers, and then we ended up. I was at an ISP, and we discovered that we could run Linux on a PC. And at that point, Intel was only doing desktop stuff at best. They were doing PCs, and no one ever thought at that point, 1991, that Intel would be the dominant force because they had these stupid little computers. So, I very much believe that that ARM has a substantial opportunity to go upmarket, like take everything it's learned from the world of single board computers and embedded systems and make things that are bigger. But you sort of have to move your way up the food chain, right? Get someone to be convinced that the $500 machine is for them. That's a challenge.
No, so I like, when I was asking you a second ago about, ARM x86, I like that you mentioned, the diversity, right? Because that's kind of what one of your main points was, like the diversity, the diversity in the ARM ecosystem versus what you have in the x86 ecosystem. And I just want to let everyone know we are going to go into talking about Packet and all sorts of other cool stuff. But I wanted to just bridge this gap here. What happens? You have a lot of experience in this. Like you've seen this technology evolve. Like, are we looking down the barrel of the ARM ecosystem transitioning into somewhat like what the x86 ecosystem looks like, where these big companies start eating each other, and then maybe you only end up with really two of these big SoC vendors. No more is that diversity there.
I don't think we're going to end up with two SoC vendors. I think ARM as a company is always going to be prepared and ready to license technology out to folks. But I do see a certain amount of, especially in server class systems. So in the server class world, Cavium and Marvell, I'll mention Qualcomm because their IP is still in the world. Ampere, Huawei, Socionext, right? So that's five, and Fujitsu because they're making supercomputer chips.
Renaissance, Action Semiconductors,
yeah. So you just keep going. So many of these organizations have designed their own cores, which is a substantial undertaking. I don't want to underestimate how many smart people and how many years and how much, megabucks it takes to design a high performance modern core, and then to engineer 24 or 48 or however many of them onto a chip. That's not a small sum of money. And one of the things that ARM wasn't doing for years was providing ready-to-use IP for servers. They were, if you wanted to do a SoC with a couple of 53s or a couple of whatever's on it, you could do that without having to invent your own core. But the high-performance server cores were all bespoke designs. And so the technology trend that I see is with ARM's Neoverse branding of things, it's going to be easier and easier for people who want to build server class systems to actually get most of the IP from ARM rather than do it all in-house and be able to spin up a chip that's got high performance interconnects and high performance cores without having to design those cores themselves.
Yeah.
That's going to take a couple years to play out. There's always the problem, the challenge, right? You announce something on day one and it takes you 2 years for it to actually hit the market. So, go ahead.
Oh, sorry. No, I was going to say, Sahaj, go ahead. I saw that you unmuted. So if you have a question, yeah, go ahead.
Yeah, you did mention Qualcomm Cintiq a moment ago. So I was wondering, now that's kind of gone. The IP is still there. Someone's selling it in China. I'm not sure, but like when it was there and it was gaining a lot of traction, a lot of people had these ridiculous benchmarks, especially with power to performance ratios against Intel machines. So there kind of a void now when the Centric socks are now gone, and are other vendors kind of filling it in? And are there still Centric servers that are operational and maintained, even though like the whole thing is kind of dead?
Yeah, so at Packet we have a batch, measured in the low dozens of Centric systems, up and running in our servers, and in some cases for works on ARM with production workloads. Production workloads in the sense of build machines. So it's no one. It's compute that if it got turned off tomorrow, there would be alternatives for it, but we really like them. There are said to be Centric motherboards inside various hyperscalers that are no longer in use or being turned down. I'm not inside those organizations, so I can't speak for them. But if someone is tired of having Centric server class systems and wants to ship a pallet of them to me, I can.
Or me.
Yeah,
or David.
we figured them out. There were some glitches at the start, but the Centrics were nice machines. They they almost qualified for boring, in the sense that it didn't take a lot of work to get them up and running, and once they were running, they just sort of kept on working. And I think a lot of the server class challenge is getting these systems to be completely dull, so that it doesn't take a lot of work to bootstrap them, and it doesn't take a lot of work to get the operating systems running. And if you want to run something, it probably just works, and just sort of ordinary.
Are we now renaming SBBR and SBBA to just boring?
Boring, yeah. SBBR and SBBR and SBSA, unfortunately, they're sort of not very fun acronyms. As acronyms go, they're not very catchy. But they make a huge difference for setting an unambiguous target for vendors to hit, and it's not a difficult lift if you're just willing to say yes, like I'll do it. The systems that Packet has been working on now, we've been working with the folks at Ampere, who have a system on a chip and a server class product that's going to go into some future Packet systems. But just trying to, make it really boring. You want to run something and it just runs. I wish the embedded world, there's ESC
EBBR.
and EBBR.
Yeah.
EBR, yeah.
EBBR being the more important piece of that. Just trying to make, it's hard enough. It's hard enough to get the software to work, and that's the fun part. But no one has a lot of fun booting things, right? That's not something that people talk about at the bar at the end of the day. It's like, oh, the system's like, dude, that's supposed to just work always. Getting systems up and running and getting you from the point of power down to operating system running, that should just happen. And it unfortunately takes a lot of work to shave the seconds off the boot process and make it very reliable and make it very ordinary. But that's the critical work. I mean, that's probably the biggest problem in the embedded space, is just how much diversity there is in the boot process.
So it's probably it's probably good news. I'll say this, that Monty on the call, we're actually working with Grant. Grant actually is a big advocate of EBBR, and Grant Likely, and we're actually working to try and make that the standard compliance for 96 boards. Essentially saying, you must be EBBR, you must follow the EBBR standard in order to be 96 boards compliance.
Yeah, that would be huge. I mean, just because every one of these little systems has some quirk to it. If we can remove the quirks, we're going to get faster, less lag between system announced and system usable. Save some months off of things.
So we kind of grazed over this, but I think it's time to talk about Packet, right? Because we never really did an introduction. Yay, Packet! We never really did an introduction to it. So maybe you could kind of tell us what is Packet?
Yeah. So Packet is a So there are hyperscale computing environments that have like enormous fleets of buildings that have systems in them. I guess in our latest newsletter, we described Packet as a subscale, not hyperscale hosting provider. We've got equipment in, I think it's like 19 data centers around the world, a mix of Intel, AMD, and ARM-based systems. The goal is that you can, like a cloud provider, use standard cloud tooling to spin up a system in a few minutes. But unlike most cloud providers that deliver that as virtual machines, we give you bare metal at the end of API. And so people like us for price and performance. People like us because we have interesting devices that are hard to get and hard to get your hands on in raw format. It's much easier if you're setting up a lab or doing some tests or doing some benchmarking to spin up a machine, have the whole machine, do your work and tear it down. That compares very, very favorably with, shipping a box into your lab.
And I think, earlier when we were talking about NUX, I think that was one of the point I was going to make was, even if you want to work towards making ARM a completely native environment where you don't have to cross compile a lot, I think it's necessary to give fairly powerful, if not workstation grade systems in the hand of developers, and systems that they can afford to buy. So I think having bare metal servers comes as close as possible to getting a system directly in their hands.
Yeah, we've had really good luck, on the ARM side of things, on the Works on ARM project in particular, which I can sort of describe. the challenge of some of these big modern software systems is that they take a long time to build from scratch. And if you're doing continuous development and continuous integration on a compiler or a orchestration environment, or something substantial, any change might require an hour or 2 hours of system time, even on a fast system. On a slow system, it might be that you could only afford to build your dev environment once a day or once a week, because it might take 2 days to hit the make command. And so one of the things that I've been focused on in the Works on ARM project is finding those fundamental building blocks of people who are doing development work, and make sure that they have access to the fastest hardware practical, so that they can cut their dev cycles down to the point where their development process can keep up with the hardware. And so it's not as much about system utilization. Like, we're not trying to keep these machines busy 24/7, although some of them are. What we're trying to do is get them so that if someone is doing CI, that it takes as little time as possible to reach a green state for things. So we've worked with, on the operating systems front, we work with the folks at Alpine, as sort of one example of things, making sure that they've got dev cycles to do their builds. Red Hat and Fedora have their own build environments, so we haven't had to help them out too much, although we've done some testing. We run Ubuntu a lot, so both Ubuntu and Debian projects have had some work with on Packet, especially the Debian folks. And then a couple of other not smaller operating systems, but there's a variety of OS systems out there. I have regular conversations with the FreeBSD folks, a couple of other BSD flavors, talking to people there. And then on the languages front, that's probably the biggest, but just by weight, the biggest effort, making sure Node.js and Go and scientific languages like Julia, Haskell. We just turned up Haskell the other day and gave them, got them a machine that could build their system in an hour and a half from scratch, which was a big advance over the previous environment they had. So, part of the bootstrapping process for a new architecture is being able to run, big software systems on it, and to not just run them, but actually develop them. And there's some limit to how much people will wait every time they check something in before they're willing to say that it's okay and the light turns green. And so that's been the big challenge.
Nice. So I have more questions. I want to kind of keep it on the Packet theme here. How big is the company? And also, maybe you could kind of just let us know, in a broad stroke, what exactly, I know that you're renting out server space, right, for the most part, but what exactly is your kind of product line when it comes to Packet?
So Packet, I always have a hard time getting a current head count because it keeps going up. But in recent memory, we had about 65 people, split about half between people who are working remote and people who are in an office of some sort. We're just bringing up a new we have a new data center up in Dallas Fort Worth that is a new project to get that going. So the product line ranges, probably the best way to explain it is, we charge for servers by the hour, either on a reservation basis where you can reserve something for the month or for the year. But the typical product is anything from a 4-core Atom or an 8-core Atom server at 7 cents an hour, up to these crazy Intel scalable machines at like $2.50 or $3 an hour. Um, some machines have GPUs. Like I say, some are ARM-based systems. There's about, I don't know, like 15 different SKUs, something like that. Again, ranging from 7 cents to about 250 an hour. Some of our newer machines we have a spot market, so you can bid for capacity that might be at a lower price as long as you're willing to be interrupted, which is perfectly suitable for build systems or other sorts of, easy to recreate work. And we've got some new GPU-based configurations where when we release them, we released them in spot market only because we weren't really sure what the price should be. So we figured we let the market decide what the price would be, and that's been an interesting process. And then from a software perspective, I mentioned that the boot process should be really boring. That's true for us as well. The easy measurement is like how many minutes does it take to boot something. Some of the more complex systems with lots of memory or lots of disk take longer, but we've been trimming away at the boot times as best we can. And in some cases, we can boot a bare metal system in 90 seconds, give or take, which is pretty interesting. The interesting thing about Packet's network is that it's all layer 3 by nature, and so it's and we fully support BGP, so it's fairly easy to develop and deploy a global infrastructure using Packet, and just use BGP Anycast routing to find the closest server. So people have been pretty happy about that as a strategy for like, how do you spread workload out over a bunch of the world. And then the latest thing that we've been working on at Packet is edge compute. So the idea there is that you're looking for data center locations that are different from the big hyperscale setups. The data center locations are going to be smaller. They're going to be closer to people. They're going to be more scattered around, like in environments that people don't normally think of as data center locations, like the base of cell towers. And we've been working hard to design hardware that's suitable for these sort of more rough and ready situations where you don't have to have someone with a PhD in cable management to rack up a rack of servers.
But so I'm sorry, I don't want to, sorry for interrupting you there, but like, yeah. I mean, you're saying like edge compute, and you're saying, finding essentially like, I want to do some edge compute, right? And I look for a location that's closest to where I'm trying to do my edge compute, because as far as, I mean, I guess that we're taking edge to, we're saying that you can be on the edge 20 meters back, basically.
Yeah, so we're looking for locations that are interesting from the network perspective, where they might be either underserved or where you can reduce latency, or simply where the economics are good, where you can put a little bit of compute somewhere and have it be managed as part of a global system and have it work out nicely. And the challenge is the compute resources that you want to deploy into these places have to be physically different from the traditional 1U rack-mounted servers that people have been selling since forever, in large part because you want to deploy them in places where you can't count on having smart hands to fix something if something goes wrong. And you really don't want to install equipment in a place where someone has to do a fancy cabling job to get everything up and running. And so we've been working with the Open19 consortium to their design for a easy to install, easy to maintain, low cable count, rack-mounted server and sled design. And we've announced that some of those, that's going to be our next our next focus on hardware. Basically, designing our own servers. We've
No, that's cool. That's actually really cool. I mean, Edge is kind of like I feel like it was a buzzword like maybe 2 years ago, but there hasn't really been much. I at least since it was kind of a buzzword, there really hasn't been so much stuff coming out. Like, it was a buzzword, and then like okay, it kind of faded off. You had AWS Greengrass coming out. I haven't seen much going on with that lately. And so, it's very interesting to see people still pushing this. And I really like it, especially when it comes to a lot of applications that we're going to be looking down the barrel of like in the very near future. You need more edge compute.
Yeah. So the obvious one is 5G, where the architecture for that cell service really depends on having compute close to the high bandwidth radios that are there. You don't want to have to backhaul all of that radio bandwidth back to a central device if you can instead do your work at the tower. And so we've been working with a couple of telcos that are really interested in that combination of 5G equipment plus locally managed tower scale compute. That's fairly early in the game right now, so there's a certain level of risk, but
yeah,
we'll try it out.
No, that's cool. Yeah. So Ed, we have a question in the chat here.
Yes.
It bridges off a little bit from what we were just talking about, but I thought maybe you would have a little input. I don't know the answer. I don't know what I would be able to answer on this. So with your expertise, let's see. It's from GRG in YouTube. Actually, I can read it over here. Hi, did I hear regular talks with FreeBSD? I hope that means a new port build box is coming. The One Thunder X the foundation has been kind of slow to build the ports for ARC64.
Yeah, so there's a call that I organize on Wednesdays at 4 p.m. Eastern. So that would be yesterday afternoon or next week, Wednesday afternoon. Sahej is on that call pretty regularly. David's been on. Carl from Packet is pretty routine there, and Ed Mast from the FreeBSD Foundation has been routine there. So I'd be happy, GRG. I'd be happy to, haul a question back to Ed and figure out what the current build box situation is for FreeBSD. I know that generally building an entire operating system is one of those grand challenges where you have this combination of lots of little jobs that need to execute fast and a bunch of big jobs that take seemingly forever. And so designing a build system that builds an operating system quickly is challenging. Just because if you keep the box busy, then at the end of the job, you've got these, compilers that are still compiling and they take hours or worse. So anyway, I'm happy to relay the question back to Ed.
Is the Works on ARM, I mean, as far as I know, the Works on ARM discussion is open to the public, right?
Yes, absolutely.
Yeah, so I mean, if you want GRG, you can send me an email and unless you want to provide your email, Ed, I don't know if you like sharing. Yeah, if you post it in the chat, then Sahaj can share it on YouTube. So GRG, if you just shoot Ed an email, he can add you to the Works on ARM talk. And I will apologize, Ed. I haven't been able to make it lately. It's been super busy. And then the one time that I did drop in, no one was there. So
we're on Zoom as well, and we had one weird week where we didn't have the right controls on the call, and it got.
Oh, so that's just my luck.
Yeah. And I don't normally make this call because I normally have other commitments at this time. Thursday noon is a busy time, but yeah. So join in. The other thing that I have that I would love to share and get some more people involved in is I do a newsletter every week on Fridays with news from around the ARM world server class stuff and single board stuff, lots of software, whatnot. And that you can subscribe to at worksonar.com.
Okay. Sahaj, if we could share Works on ARM also.
Yeah, so and that newsletter, I think I'm in issue, I want to say issue 70, something like that.
Oh, wow.
And all the back issues are online, so it's mostly, it's 500 to 1,000 words a week, mostly just news clippings from various places. Try not to editorialize too much. Try not to dip my hand in controversy about who might be doing what, because there's enough just straightforward news to cover. The worksonarm.com site also has a pretty good sized directory of software that we have used and either support directly or have commercial support that's been tested on server class systems. It's only a small subset of all the packages that are out there, but trying to work with various, part of the Works on ARM project is working with various open source projects and commercial projects to get to the point where 64-bit ARM builds are first-class citizens in their build process. That's the easy part is usually making the software work, because after a year plus of doing this, most of the rough edges have been worked out. But people's build systems can be really crazy, and they're all really different. And so working with people who have build environments to get enough infrastructure, either CI/CD system infrastructure hosted, their own CI/CD running on ARM systems, every once in a while cross-development environments when they make sense, and just getting the stuff packaged and ready to go.
Nice. Yeah. So Sahaj, I'm gonna pass this over to you because I noticed that you still have a few more questions in here. So just to let you know, Ed, we have probably anywhere between 5 to 10 more minutes left.
Yeah.
Before Sahaj takes over, I want to kind of emphasize on this, but definitely go take some time and check out the packet.com website and the Works on ARM website. There's a lot of really cool stuff to read through and a lot of cool stuff to check out. So, we have Ed here. If anyone is still in the channel that has questions for Ed, we do have about 10 minutes left. Feel free to speak up if you're on the Zoom channel, and if you're on the YouTube channel, bring your questions or join us on Zoom. Ed's here for a little bit longer, so you can get your questions answered, and don't forget to go check out those websites. But Sahaj, so if you want to get your questions going.
So I think I'll pass this over to Mani because he has a very interesting question on the topic of ARM servers. So.
Oh, that's Mani's question. That's good. Yeah. So we have a list of the questions here. Yeah. Maybe Mani. There he is.
Hey, Mani.
Hey, Ed. So my question was, how much time do you think it will take for the RISC-V ecosystem to establish itself in server market?
So RISC-V is really interesting. We're at the stage of RISC-V where there's a couple development boards out there. There's no standard boot process. There's nothing server class yet, or not really to speak of. But people have fresh in mind the experience of doing all this for the ARM ecosystem and all the interesting things that have happened along the way to make that happen. So I'm hoping that RISC-V's process from where we are now to having systems that are boring RISC-V systems will not take as long as it has seemed to have taken in the ARM world. Server class is a little bit harder because you sort of have to walk before you can run in a lot of these systems. I know that people are talking about RISC-V cores as cores in designs that kind of smell like GPUs or TPUs, or like lots and lots of little tiny cores all working in parallel. So there might be some interesting, design work there. I think we're a couple years off from servers, just because it takes Silicon a couple of years to happen. And I think from a design perspective, if the RISC-V world wants to go faster, I think it needs to focus on getting some standards at the getting enough standards involved so that the bootstrapping process and getting new machines up is easier.
Yeah, I think
Agree with that.
what
Go ahead.
Yeah, just one more question. So, do you think that free ISA like RISC-V will have some kind of influence when compared to closed ISA like ARM?
I think it'll have an influence because at the very bottom of the market, where people are trying to save pennies on a chip, free is good. I don't think it makes as much difference as you go towards server class, because there's so much more IP that goes into these systems, more than just core design. I think it's healthy for the world as a whole to have another interesting ISA. But as someone pointed out, being able to really do development on a given architecture involves having substantial machines that you can build that you can build your compilers on, for instance, and rack mountable, easy to network boot systems. And they characterized 3 architectures as production ready right now: x86, ARM, and Power. And they put MIPS and RISC-V as science projects. Nothing wrong with science projects, but very, very difficult to get a system that's up and running on those architectures right now. I think MIPS is really the other interesting one there. They just announced open sourcing the cores for that, but people have just complained it's very hard to do development for MIPS because it's very hard to find a box that's fast enough to build on. Because the ISA the silicon is really not kept up. So I think it's we've got a couple interesting years ahead of us. I think it's much RISC-V is really interesting in the embedded controller space, and I think it's there's going to be some innovation coming from the RISC-V space that's going to be shaped differently from innovation in the ARM space, just because of the openness and people are going to be willing to try things out.
That answer your question, Mani?
Yep. Thanks a lot, Ed.
Good. I mean, I'm by no means an expert on this stuff, but just watching the enthusiasm around RISC-V and the half a dozen cities around the world that have RISC-V meetups that are well attended. I've been to one of them in San Jose. Lots of interest. Translating interest into production ready stuff is a very different step.
Mina, you say you're not an expert, but I think you're definitely the most expert of us.
Well,
so,
that's a little scary.
we'll take your experience and we'll all learn from it. So Ed, I want to say the stuff that you're doing with all of the server space is amazing, because it's been kind of, like you said, too long, right? Like it's been too long for this stuff to happen. But I kind of want to ask you a question about ARM servers, right? And you said like at Packet you have your your x86, Intel, AMD servers, and then you have your ARM servers, and this is kind of your specialty, right? Like you're the works on ARM guy over at Packet. Yeah. So let me ask. I mean, besides and this might be kind of maybe I want to call it maybe a dumb question, but besides the just the simple things of saying like, okay, well, I don't want to have to cross compile. I'd rather just work on ARM. what are some other things that would motivate someone to literally just choosing an ARM server over an x86 server? And I mean, like, I've had people, approach me with their perspective, like, okay, yeah, power management and, costs and space, with everything. I've heard everything under the sun, right? So I'm kind of wondering what your perspective is, something that would drive someone to choosing an ARM server minus the cross-compiling aspect.
Right. So most
and the diversity aspect.
Right. Right. So most of the work that I've done, because of the nature of the work it is, have these machines as build servers, right? So if you subtract out all the build farms, if you subtract out all the, building for embedded systems is a really interesting use case. The folks at Resin, or I guess they're now called Belina, have some really good, powerful. Why should you, use ARM servers? Because they go faster to do that task. But if you're just looking at general purpose compute, that's a harder sell. The most compelling story has been the people at Cloudflare who did the big teardown of how they could support the same workload at about half the power consumption. The folks who are using ARM servers at Packet have found, just because of the way we announced it and the way we priced it, it was the cost-efficient way to get lots of memory for a system, because you're spending less on your processor and you can spend more on the memory, and the memory performance of most of these systems is really quite good. So you have an IO bound, memory bound, but not CPU bound process that works pretty well. Things like terminating lots of connections on a front end for a network service or whatnot.
But so I'm sorry for interrupting, but so like I guess maybe I'm fishing here, but I was at the Qualcomm campus here in San Diego not too long ago, and they had two laptops, right? It's called them, I think, they were Chromebooks. What was it? Qualcomm released their, I think it was like an 820 Chromebook recently. Oh, you have it?
No, I don't have it, but they've got a whole big line of super power efficient, always on internet.
Yeah, always connected.
Yeah, always connected.
Yeah, and so my question is this: like when I went to the campus, they have this showroom. They show the two laptops. One's running x86, one's running ARM, and then they have this the thermal camera, right? And the thermal camera is basically showing both these laptops. The x86 one's just freaking glowing, and then the ARM one has like a nice little glowing spot, but it's blue all around. Like it's you can basically relate or correlate heat dissipation to energy loss. Right. And so essentially you're saying that these ARM devices are able to last longer. Right. So, I mean, like if you applied this to a server farm, you walk into a server farm that's full of ARM servers, that room's going to be less hot than the server farm that's powering the x86 servers. Right. Which, I mean, are you getting the same compute, though? So
there's trade-offs in all of these things. Right. If you're running a Thunder X2 system full bore with a full complement of memory and a bunch of SSDs and like everything in it, that's not a 5-watt device, right?
Yeah, but the SoC is.
Well, it with any of the SoC SKUs, you have a lot of performance and power tuning available to you. If you want to run it at full performance, like if you want to turn on all the cores and have them all run at the highest clock speed, you're going to consume considerably more energy than if you detune it a little bit. So it's not linear. The curve goes up the more performance you try to squeak out of something. So from a price performance basis, it's not a slam dunk that the ARM systems will be less, they'll be more power efficient. They tend to be, but it depends on what part of the performance envelope you're in. Amazon has its new A1 class devices that are like 16 core, 2 gigahertz or so systems. I think they've hit a pretty good spot on the power price performance curve for that, just because they are reusing the same chip designs that they're using in the NIC. So they already have a pretty good handle on, what trade-offs they were going to be able to make. If you look at some of the options that a place like Marvell will give you for different chips, you've got literally hundreds of different options. How many cores, what clock speed, are all tunable. I mean, they may be coming from the same wafer, but you just underclock them to save on power. So I think we still have a couple of generations of core design left in the ARM space, where the cores themselves would be more performant and use less power and or get better performance at a good power rating. In the server space, the goal really is to just be completely boring, to have systems that look and behave just like their x86 cousins, and then stepping up from there, try to take advantage of some of the other diversity in the hardware space, whether it's accelerators or on-chip algorithms that go really fast or what have you. I don't want to. I think we're still at the stage where we're developing the ecosystem. Some of the chips are really boring, but most of them aren't. And so if your use case fits inside the systems that are out there right now, I think ARM is just definitely worth looking at. Certainly from a longer term perspective, I think it always helps. I've always been a fan of portable software, right? So you don't have to be completely dependent on one vendor for the work that you're doing. And so that every time you're doing a design, you can look at the whole landscape and not just the thing you had before to get the workload you want done.
Yeah.
About the ARM server world, I mean, to be super honest, the thing that we've been most frustrated by is just availability of parts. You want to buy a server or you want to design a server, how many vendors can you go to for parts, and how long is it going to take you for you to get them, and will they all be in business in the time frame that you're making decisions? And the Qualcomm experience, was, I don't want to call that a setback because I think other vendors have stepped into the fray, but it would be a lot easier if we could buy Cintiqs. It'd be a lot easier.
Yeah, I mean, that's kind of that's one of the perfect examples, right, of like what you mentioned, but it's also kind of an example of why 96 boards came to be. I mean, if you look back at the history, 3.5, 4 years ago, it was high cost, high lead times, and variety. We wanted to tackle that issue. It's like, let's put all these bleeding edge SoCs on a standardized form factor, bring down the cost, and there you go, and bring down the lead times for these boards.
Yep, and also bring down. I think your next challenge. I'm really super interested in the eBVR stuff. Bring down the lead time of getting a full software stack up and running. Software
compliance, Monty, you hear that? It's been something that's been in the works for a long time. So finally, it seems finally we're going to start trying to move forward on it. We've always had a hardware compliance. We've had somewhat of a software guideline. We've tried our best to make sure that 96 boards, what we want is we want open source, we want upstream, we want people to be able to like you said, boring is better, right, in a lot of cases. And so we want that experience to cater to a lot of these big operating system communities and operating system layers, application layers, et cetera, enabling people better development environments. And
Right.
that's kind of the goal. Yeah.
No, I think it's a great goal, and trying to go up the stack, hardware standardization so they're easy to plug into each other, boot standardization so that they're easy to get into a kernel, and then upstreaming all the kernel stuff. I mostly take over once the system gives you a prompt. Most of my work has been post boot, but it's very clear that just that continued emphasis on you take something out of the box and how long does it take you to get it to the point where you're running Kubernetes or something.
So Ed, I think we have to kind of start closing out here. I do have one more question on the chat. Then I'm going to give you a chance to kind of close out any plugs or anything you'd like to say. But this is from GRG. Says, you probably can't answer this, but when will ThunderX2 and Ampere Emag be generally available on Packet?
So we've announced that our new microserver design that's going into these Open 19 sleds is going to be all three of Intel, AMD, and Emag. That was I think the target for that is first quarter this year, but I don't have a specific date and I haven't seen those servers yet. So I don't want to promise a particular date, but I do know that that's in the works. ThunderX2 is going to be a lot more limited. We've got a handful of servers that are in our Works on ARM project for projects that people can describe what they'd like to do and we can consider it. But at this point, based on ThunderX2 is a super interesting machine. But for what we were thinking of for a general purpose compute for Packet, it's much more of a high performance computing device than it is a workhorse device. It's kind of hard. It's been harder to understand how we would bring that to market as a sort of a standard part.
Yeah. All right. Well, hopefully that got you there, GRG. Thank you for the questions.
GRG, definitely send me an email and we can sync up. I think there's a bunch of things we can talk about. So
awesome. So Ed, now it's before I do my little closing announcements, we did go like 7 minutes over. I'm sorry. I hope I didn't eat into
no worries.
the workday. Go ahead, closing remarks from you. Is there anything else that you wanted to talk about before we close out?
This is where I talk about my SoundCloud, right?
This is where you get your plug. You've already endured my Sahaj and mine my questions for an hour. Now you get your plug.
Yeah. So the plug is I suppose the best plug is follow me on Twitter. There's 2 accounts. There's Ed Vielmetti, which gets the sort of random stream of whatever I'm working on, which might or might not be ARM related. And then there's the Works on ARM feed, which is mostly retweets, but I try to scour the net as best I can for people working on ARM things and improve the visibility of what they're doing. So if you have an interesting project, definitely let me know. I will definitely share it with the various folks, either via Twitter or via the mailing list that I run. The mailing list has a couple hundred subscribers. I think we're up 225, something like that, including a bunch of people inside chip makers who you normally can't get a hold of. So I've been really happy with that result. And yeah, just sign up for a Packet account. Let me know that you signed up, and I'm happy to throw some credit your way. We're always looking for people who have an interest in bare metal compute, who can make use of the whole machine. And drop me a line.
Awesome. There, yeah. So we shared actually we just shared the links to your Twitter accounts, and then I just signed up for your newsletter. I didn't even know you had one, to be honest. That's my fault. Sorry. But I'm excited about that.
Cool.
So yeah, Ed, thank you so much. It was a pleasure talking with you. you're welcome back anytime. So if there's ever any cool things that you end up doing or that you'd like to show us, if you're ever walking around one of your server rooms and you want to tune in and show us what's going on over there, that would also be awesome. But yeah, thank you for your time.
Happy to do it, and look forward to syncing up with you again in the not too distant future.
Yeah, Ed, before you go, can
Yeah.
we maybe get? I still have a few more announcements, so don't go anywhere.
Yeah, I won't go.
You're welcome to. Okay, cool. So if you don't mind, real quick, I just want to share these few announcements, and then I'd like to take a selfie with you. So it's something I've been doing lately. So real quick, we did release several new boards these last couple of weeks where we've been kind of on hiatus for the holidays. We have the FPGA mezzanine from Shiratech available on Arrow. All of these boards can, of course, be found on the 96boards.org website. One that was released, I believe it was just yesterday, was the Trezor mezzanine. You can go check that one out. We have several consumer edition boards. One is the Parrot by High Chips, the Sophon Edge by Bitmain. So, I mean, if you're familiar with Bitmain and their work in the cryptocurrency world, I have one of them right here, and I haven't opened it yet. So maybe we'll do an unboxing next week or the week after. Actually, I got to do it sooner than that. So maybe Sahaj and I will get on a Tech Talk live stream and unbox that.
That's a nice box.
It's a nice box. It looks really cool. It looks like you bought it from Best Buy. We have Oxalis, which is an enterprise edition board. This one just came out recently, and the Wiz Trio, which is an IoT edition board. And they keep coming. We have like this list that's like this long with 10-point font. That's a lot. So definitely keep your eyes on the 96boards.org website, at 96boards on Instagram, Twitter, LinkedIn, you name it, we're there. So find us there. Last thing, next week, we will be meeting with some amazing people who built projects for the ARM AI robotics contest that happened through Hackster Io several months ago. It just ended. They've announced their winners. We have upwards of 6 people joining us next week. So it should be a very interesting episode. We're going to give each of them about 5 to 7 minutes to talk about their project, possibly show us a demo, and then we'll get to see all sorts of cool stuff. This is not just stuff that was done on 96 boards. We have stuff done on Raspberry Pi. And then we did have one awesome project that was submitted on the Ultra 96 FPGA board by Avnet with the Zinc UltraScale SoC from Xilinx. So there should be a lot of cool stuff next week. Definitely tune in, set your calendars. We will update the website on 96boards.org/OpenHours, hopefully within the next couple of days, so you'll be able to kind of see what's going on and set your calendar links. But thank you very much. This has been episode 129. Ed, you're awesome. Thank you for your time.
Thanks very much.
Thank you. Now I got to close out the recordings. Bye, YouTube. All right, let's see how this goes. Stop live stream to YouTube.